Okay guys, let's start class. Yeah, I'm just gonna share my screen. Okay. Oh gosh, it's 360p. Okay, whatever. Yeah, it just does that to keep the latency low. Wait, what are you talking about? I'm not trying to mute anybody. I don't know. Okay, so let's start today's class. Let's start today's class. In today's class, we're going to be learning about polynomial functions, or Unit 2. Okay, so first thing to learn about, polynomial functions themselves. So, as you can see here, there's a bunch of function pictures and graphs. There's a bunch of function graphs. So if I get my annotation tool and I look at this, no, I don't think so. So this function has a degree of 0. So first let's find out what a degree is. So every polynomial has a degree. So you see x has a degree of 1 because there's an exponent of 1. If you were here in the last crash course that we did, then you would know what a degree means. So basically, it's like the highest power. So let's do an exercise here. I'm just gonna write a random polynomial. Okay, it's gonna be squared minus y cubed plus x to the power of 2 minus 5. Okay, so let's see. You can just shout it out. Who wants? So, what's the degree of this polynomial? You can just shout it out.
It's 3.
Okay, so good job, but
3 is the exponent, right? That's why it's equal to 3.
yeah, but so the highest exponent in this is obviously 3, right? Yeah, the biggest exponent, and it's 3. Okay, but remember, so terms. So does everybody know what terms are? Can somebody explain to me what terms are?
Terms are like x, y, x, that.
Okay, so yeah, you're right. That's an example of terms, yeah. But terms basically are anything without addition in them. There can't be any addition or subtraction. There can only be multiplication or division. So this right here is a term. Even though these two are getting multiplied, this is still one term because there's no addition in between them. This, see right here, these two, is not a term because there's an addition over there. So that's basically what terms are. And good job, Manya. So basically, yes, the highest exponent is 3, but the degree of this function is actually 5 because the terms degree, or basically if you add these two exponents, then it becomes 5. Okay, so it has to have the highest total degree, or basically you have to add up all the exponents in the term, except for 1. If you have a 1, then just ignore it. You're not supposed to add that. I mean, no, sorry. You should add a 1. Okay, so yeah, just add up all the exponents in there. Okay, and whatever is the highest number you get, that's the degree. Okay, so yeah. That was a trick question. But let's go for an easier one.
That was a trick question?
Yeah. Because the degree is 5, remember? Yeah. Okay, so let's go for an easier one. What do you think the degree is for this?
5, 1.
It's actually 0 because
Because there's no exponent.
no, there's an exponent of 1 over here, even though it's invisible, there's a 1 over here. But the reason is there's no variables in this. And the only things that count toward the degree are variables. Okay? So that's the reason why this has a this is easier, isn't it? Because there's not as many numbers and stuff. There's only one. Okay, degree. Yeah. Of 0. Yeah, this was another trick question. Okay, so yeah, that's basically it. So yeah. Okay, how about you do this one? Plus 5.
Okay, so can I go?
Sure.
Figure out the degree.
Yes.
For which one? Exponent 3?
This whole thing. The degree of this whole polynomial.
Wait, so you have to add it?
No.
Answer?
Yeah.
The degree would be, I mean, if this is not a trick question, the degree would be 3.
Yeah, this isn't a trick question. So yeah, you're right.
Yeah, I was thinking 3.
Yeah, it was 3.
Oh,
Okay, so this is what a degree of 0 function looks like. See, a constant function. There's no like change. There's no slope or anything. It's just a straight line. That's what a degree of 0 looks like. This is a degree of 1. It's a linear function. There's no exponents in this. There's just a 1 exponent. And this is a degree of 2. Quadratic function, because a quadratic function equation looks something like this: x squared plus, so ax squared b x plus c. This is what a quadratic function equation looks like, and this is equal to y. So yeah, this is what a quadratic function equation looks like. And a cubic function is the same. It's almost the same thing as this, except there's an x to the power of 3, and this one there's an x to the power of 4. It's a quartic function because x to the power of 4 for the 4th degree. And then there's a 5th degree function, quintic function, basically. And yeah. So as you can see, the max real zeros of each of the graphs is the degree. See, if you see here, the degree is 0, and so there's 0 zeros, basically. Okay, and over here at degree 1, there's only one real degree, and over here at degree 2, or quadratic functions, there can be 2 real zeros, and so on and so on. There's until like forever.
In a polynomial, can there be two degrees in one number? So for example, if you had 5, and then you had 3 on it, so you had a 3x as an exponent, and you had a 3x as an exponent, so they're both degrees. So can you have 2 degrees?
No.
Okay.
And
then what do we do
if there's the same thing, if there's like 2 same big exponents, or 2 terms with the same exponent, and that's the biggest one there is, then you just take that one. You can't have 2 degrees. Yeah, but the biggest one in the whole thing is still 3.
So the degree is 3.
Yeah, still, yeah.
Okay.
Yeah. Okay, good question, Neil. So here's another question for you guys. State the difference between the odd functions and the even functions. Okay. Who wants to go for this one? And by odd functions, I mean like odd degree functions. See, this has a degree of 0. This 0 is an even number. And this has a degree of 1. Sorry, this has a degree of 2. 2 is also an even number, but this has a degree of 3. And this is not an even number, this is an odd number, right? So yeah, that's what I mean by odd functions and even functions. So, does anybody want to go for this one? Nobody? Not even Sid? Or Manya? Okay, so basically the difference is, if you look over here, see for even degree equations, like both of the ends point in the same way. This one points up and this one also points up. For this one, it's also the same thing. This one points up, this one also points up. But for odd degree equations, one of the sides points down, most likely the one on the left, and the other side points up, as you can see. Also the same case here and here. So yeah, that's the difference. I think that's it. There's not much to it. That's it. Let's move on to the next slide. So you can also do like long division with polynomials. So basically, long division looks like the same thing. Looks the same and is the same as normal division. As you can see, you set it up the same way. There's like this thing with a line on top and stuff, and you write your dividend in here, and you write your divisor in here place, and the quotient goes on top, just like normal division. Almost no difference, barely an inconvenience. Okay, so now to basically solve this, it's still the same method, except that it's just a little bit harder. So basically, you can just do, it's the same thing. Like, I don't remember like the acronym for like doing it, but like you have to like divide and then you have to like multiply. If you remember that, does anybody remember like the acronym for long division? I don't remember those kinds of things. I just does anybody remember the thing for that? The acronym for that? Nobody?
Acronym for what? What is an acronym?
Acronym means like it's where you have like a short phrase for like a long thing, and then there's like another like long thing that helps you remember. You know, like the 9 planets.
So dividing polynomials are basically long division?
Yeah. I don't remember. So it's like something like divide and then multiply and then.
Okay.
So does anybody remember like this thing for like long division? It's like
I don't even know what that is. I don't remember.
dm something something. Let's just write it down. I think I know it. Uh, divide, multiply, subtract, and repeat. No,
Is it PEMDAS?
no, that's not what I'm talking about. I guess it doesn't matter right now. That was just like a. It's basically the same process. Long division is the same thing. Polynomial long division is the same thing as normal long division, as if you were to do like 21 divided by 7. So, no, that's way too easy. Let's do 3, 4, 3 divided by 21. Sorry, divided by 7. So the first thing we do is basically we divide. So we try to look at what like thing it's there. So like 7 times 6 is 42. So that's obviously not going to work. Oh, yeah. Okay, so yeah. So 7 times 6 is obviously not going to work. 7 times 5 is 35. So this is just 1 less than 35. So so it becomes 4. 4 is on top. You multiply 7 times 4, that's 28. And you do 34 divided by, 34 minus 28, and you get like 4, you get 6, over here, and you keep doing it until you solve the problem. 7 times 9 is 63, so minus 63, and that's 0. So yeah, you know this long division? It's the same process for polynomial division, except you have like more stuff to do, you know. So let's do the example that they gave us. So they have 2x to the power of 3 minus 5x squared minus 8x plus 15. Okay, so let's just write that down for now. And let's do x minus 3. So now we can like do the thing. So basically we have to look at this, and we have to look at this, and you can see that they're doing times 2 to get from here to here. And they're also doing times x to the power of 2 to make x to the power of 3. So we can just write down 2x. Yeah, it's a live stream. There's a live stream. So yeah, then you just multiply this across, and it becomes 2x 3 minus 6x squared. Supposed to be squared over here, and then you like do this, and you're supposed to subtract this whole thing. There's like, and then you're supposed to distribute the subtraction sign. So you have 2x cubed minus times a negative, and negative 5x squared times a negative. So this becomes this, because you're like subtracting it, and this cancels out. Then you have x squared over here, and and you have to bring this down, and it becomes minus 8x, and so you have to multiply by positive x to get x squared. So you do that, x squared minus 3x. Then you have to subtract, so you're gonna turn that into a minus, turn this into a plus, cancels this out, and now you have negative 5x plus 15. And to get negative 5x, you have to multiply x times negative 5. So you have negative 5 on top. Negative 5 times x is negative 5x. And negative 5 times negative 3 is obviously plus 15, positive 15. And if you like subtract this, you get 0 as the remainder. So this is the solved thing, and as you can see, it exactly matches up with what they got. So yeah, that's pretty cool. That's long division, super easy, not barely an inconvenience, not hard at all. So now let's do some practice problems on this. Okay, so first of all, we're gonna do some practice problems on let's go back here, and we're gonna do the practice problems on the polynomial functions first. So if you go into self-check, start this. Okay, let me zoom in. No, I don't think I need to zoom in. Okay, there we go. Yeah, gets bigger. So determine whether the degree of the function in the graph is odd or even, and find the maximum number of real zeros the function has. Okay, so who wants to do this one? If you want to do this one, then raise your hand in the participants list. Okay, Satvik, you want to do this? You can do this. There you
go. I think it has 4 zeros.
Okay. And is it odd or even?
It's even.
Okay. So it actually has 3 zeros, and it's odd because remember like that trick I told you about, like the pattern, like if it points downward, and the other like side points upward. If this arrow points upward and this arrow points downward, then you know that it's going to be an odd function. So that automatically rules your answer off. It also rules off 2 and 0. So the only like 0 you have left is 3. You have 3 zeros left, that's it. And 1 0, but like 1 0 functions don't look like this. 1 0 functions are linear equations, which look more like a straight line. It's slanted. Yeah. So that's why that answer is wrong. So yeah, good job, Satvik. Let's go on to number 2. Find the f of x. Find f of negative. Okay, so we're not going to do this. We haven't learned that yet. So no. And what is no? Determine whether the degree of the function in the graph is odd or even. Find the maximum number of real zeros the function has. So let's go with Sakti for this one. Sakti, you can do this one.
It's 6 zeros.
Okay.
Even.
Good.
I mean 4.
4 zeros, are you sure?
Yes.
It's actually 6. You were right the first time. Because it's like 1, 2, 3, 4, 5, 6. Right? So it's 6 zeros. Yeah. So good job, Shakti. Let's go on to number 6. Sri Lakshmi, you can do this one. This is super easy. Like anybody can do this.
Does it? One sec. Does it have 4 zeros?
Yeah, it does. As you can see, there's like 4 turns in this. See, it goes like this once, twice, thrice, and 4 times. So yeah, that's 4 zeros, obviously. Good job, Sri Lakshmi. And and 4 is an even number, so obviously it's an even function. So yeah, and let's go on to number. Okay, so let's learn how to like solve a function for a given value. So let's learn that right now. So annotate. So here, as you can see, like this is saying find f of x. Sorry, find f of -8 for the function f of x. See, and f of x has like this whole thing. F of x is this equation right here. And so how exactly do you do this kind of problem? So basically what you have to do is you have to substitute -8, because it says solve f of a -8. It says find f of a -8 for the function f of x. So you're supposed to replace wherever you see x with -8. So that's super easy also. So you just do negative 8 to the power of 4 plus 6 times negative 8 to the power of 3, power of 4, and 6 times negative 8 to the power of 3, and you have plus, oops, you have plus 261 times negative 8 plus 1109. So yeah, now you just have to simplify all of this. So negative 8 to the power of 4, let's find the value of that. 8 times 8 times 8 times 8, and that's 4096, so that's 4096. And yes,
Can you hear me?
yeah,
Can you hear me?
yeah,
You can hear me?
yeah,
Can you hear me now?
yeah.
Oh wow. So these actually do work. I'm using AirPods, but I'm like at another room, and you could still hear me.
Okay, it doesn't matter. Okay, so,
What do you mean it doesn't matter? It does. It's awesome.
okay, I think you're just using your laptop audio, I'm pretty sure. Okay, so, so we have 4096, and yes, I know that there's a negative, so this negative actually doesn't matter when you have an even exponent, because it just gets canceled out, because negative times a negative is a positive, and you have two of positives, so you have negative times a negative times a negative times another negative, and so this becomes positive, this becomes negative again, because positive times a negative is a negative, and then you have a negative times a negative again, so it becomes a positive number. So yeah, that's why even even if you have like a, Neil, can you please mute yourself? Okay, so even if you have a negative or a positive number, it doesn't really matter when you have even exponents. Okay, so let's move on to this term right here. You have 6 times negative 8 to the power of 3. So let's first do negative 8 to the power of 3, and that's obviously 512. And you have to do 512 times 6, which is a huge number, so I'm going to use a calculator. 512 times 6 is 3072, and then you can just like write that down. Plus, when it's an odd number, you have to actually like carry a sign, so it becomes negative 3072, and you have plus. So now you have 261 times negative 8. So let's calculate that. 261 times 8, and so that's 2088, but it's going to be a negative because it is. So that's a negative, and I forgot the thing. Okay, let me just do times 1. Okay, so it's 2088. So it's negative 2088, and you have plus 1109. Normally the equations aren't this complicated, so you probably won't get this big of a number to deal with. So, but we're just going to use the calculator to find this answer. 4096 minus 3072 minus 2088 plus 1109, and that equals 45. So yeah, 45, we put 45 in here, and that's probably the right answer. Okay, so Who wants to do this one? This number 3. If you want to do this one, then raise your hand in the chat.
Wait, can I?
Yeah, sure.
Find f, which is times -8, for the function f times x. F times x is equal to f.
Okay, so first of all, this is f of x. It's not f times x. I can.
You were doing number 2. You're doing number 3.
Yeah, I just found the value of number 2, and so were you listening when I showed you how to do it?
What?
Do you know how to solve this kind of problem?
Do it. I think I could do it.
Okay. So how are you gonna do it? What do you do exactly?
Is it 10? 10.
How did you get that number?
Well, basically, first of all, what I did is that I know that f is equal to, 2x and exponent 4 plus 10x exponent 3 plus 124. Okay? Then I multiply that and subtract it by 3.
Okay, yeah. You multiplied that by and subtracted by 3. That's not how you do it. So, basically, what I did here for this problem, which is what I was talking about, is basically so you have f, and this is not times. Okay, this is f. So if you have something like f, and then there's like parentheses, and then there's a number in there, then that means you're doing a function. You're trying to solve the function for some value. So right now this value is -3. So you see how there's like an f of x over here? That means you're doing the function of x. That's basically kind of what it means. And x is the variable that they use in this. So that's why there's an x over there. So, so when you do this,
Was my answer correct?
I don't know. So when you do this, you're basically taking x out, and you're putting -3 in that place. That's basically what you're doing. Or, in other terms, you're substituting -3 for x. So for this f of x equation, you just take -3 and then every time you see an x, you take out the x and put a -3 in there. So basically, what you have to do is you have to do 2 times -3. We're gonna find out if your answer is right. So you do 2 times -3 to the power 4 plus 10 times -3 to the power of 3 plus 124. Okay, that's a 4. 124. Now you just simplify this expression right here. So what you do is you do 2 times -3 to the power 4. So you have to do -3 to the power 4. And remember, like I said, when you have a negative, it doesn't matter if you have a negative or positive number. When you have a even exponent, then you're going to get a positive number, whether or not you have a negative number in the place that they're supposed to be. So there's x. This is 3 to the power of 4, and that's 81. It doesn't matter about the negative when there's an even exponent. So that's 81 times 2, and that's 162 plus -3 to the power of 3. That's -27, because this is an odd number as the exponent. The negatives do matter. So you get -27 times 10. So basically you have a negative answer. So that's -27 times 10. That's -270. and then you have to add 124, and because there's no x in 124, you don't have to multiply or do anything to it. That's a 124. So you have, let's just use the calculator for this, 162 minus 270 plus 124. And you get 16. That's the answer that you get. And so I guess do it. So 64, I'm pretty sure. No, was it 14? I think it was 14. I don't know, let's check.
So the answer
No, it was
is
16.
14.
No, the answer is 16 actually. I did it on the calculator, but I forgot the number. The answer is 16. Yeah.
Okay, that means I was close.
It doesn't really matter though because you just guessed the answer. Do you understand how to do these kind of problems now?
Yes.
Okay, then how about you do this next one? Let's see.
Wait, actually, I don't understand it that much. Can you repeat it again?
So
It's kind of confusing.
it's not really very confusing at all. It's just a little bit like hard to do, and it's just a little bit tedious. So what you have to do is you see this f of negative 3 right here, right? So let me zoom in. Oops, okay. So what that's basically saying is it's saying that you have to replace x by negative 3. Every time you see an x, you have to put a negative 3 in that place, as you can see, as I did here.
Okay, okay.
And then you just have to solve that expression. You just have to simplify that then, and then you get your answer. It's really not that hard to understand.
Oh, okay, that's easy.
Okay, so Neil, how about you do this one, number 10.
Okay, find x minus. Okay, so it's the same thing. Change everything as f in x into minus 3. So that would be, first of all, it would be f, minus 3 x in 3 plus 5 negative 3.
Yeah, keep going.
And then exponent 2 plus 101.
Yeah. Okay, so
Okay, now solve the expression. Okay, just wait. Okay, so minus 27 plus 40. Wait, so negative plus negative plus positive is equal to negative, right?
that depends on which number is bigger.
Okay, so 45 is bigger. That means it's going to be a positive.
Yeah.
So 27 plus 4 is equal to, okay, so if I solve it, that would be 173.
Okay. I
And
think
do you
that
have to simplify it?
100. You got 173, right?
Yes, and do you have to simplify that?
How would you simplify that?
I don't know, I'm just asking, how do you have to simplify it?
Yeah. Everything has to be simplified, unless the directions say so.
Okay. So simplify 173, right? Okay.
There's no way to simplify 173.
Oh. Yeah, there is no way.
Yeah,
It won't
exactly.
work. It'll be like a decimal. It won't work.
There's no way to. Simplifying means like if there's a fraction, then you're supposed to put it in the simplest form. Yeah, there's no way to simplify like just a whole number, and that answer is still wrong because this is a negative 27, not a positive. So I think it would become...
Won't the answer equal to a positive?
Yeah, it will. Yeah, but it's not going to be 170, whatever you said. It's going to be 119.
How is it going to be 119?
Because you add this, so you can just add it in your head. It's super easy. It's
That's of course 146.
Yeah. Then you have to subtract 27.
Oh.
Because this is a negative number, right?
Can I do one more, please? Now that I actually like completely get it.
Yeah, sure. Actually, how about not? Let's let somebody else do this.
Okay.
So who wants to do number 11? Sujit, do you want to do number 11? Seems like Sujit is not here. Midlesh, do you want to do number 11? Hello, can everybody hear me?
I could hear you.
Is anybody here?
Can you hear me?
Yeah, I can hear you.
Okay.
I can hear you guys.
Okay, so it seems like nobody else wants to do it. Satvik, do you want to do this question?
Okay. I'll try, I guess.
Wait,
Okay.
is it hard?
Okay. You do x power 2 minus 3x minus 25.
Yeah, there's a lot of background noise.
Yeah.
Yeah, that's Satvik that has a background noise. That was loud.
Now can you hear me?
Yeah.
But there's still a background noise.
It's not as bad as before.
Okay,
Okay, it's bad now.
So you do x power 2 minus 3x minus 25. Can anybody hear me?
Yeah.
I can hear you. What's up?
Well, it sounds like nobody can hear me.
What do you mean?
Are you watching?
Me?
Is somebody in your house watching the TV or something? There's like a bunch of background.
That's our TV.
Yeah.
That was very loud.
So how exactly would you do this problem, Satvik?
Can you hear me?
Yeah, I can hear you. So Satvik, how exactly would you do this problem?
I guess I would do 3 power of 2 minus 3x.
Why would you do that?
Okay, I would do 25 power of 2.
No, you would do 4 to the power of 2 minus 3 times 4 minus 25, because as you can see over here, it says f of x, sorry, it says f of 2 for the function f of x, and f of x is defined over here. So you have to replace 4 every time you see an x, and you're supposed to do whatever it says. See, there's an x squared over here, so you're supposed
Okay.
to replace 4 in place of x. So you do 4 squared, and then there's an x over here, so you do negative 3 times 4, and then there's no x over here, so you just do minus 25. So yeah.
Okay. So you do 8 or 4 power of 2.
4 to the power of 2 is 16. 4
yeah,
times
okay.
4.
Yeah. And then you do 3 to the power of 4. And you do minus 25. So it's 16 minus 12. I mean, no, not 12.
Yeah, it's 12.
Okay, 12 minus 25.
Okay, and what do you...
So, I have to add all of these up because minus plus minus, so it is plus, so
Yeah?
it's 53.
Um,
I mean, it's negative 53.
that's still wrong.
It's wrong.
Yeah. See, this here is a positive number. This is negative, and this is negative.
Okay. So a positive 16 minus a negative 12 would be a 4. Okay, so it would be negative 21.
Okay, good job. Negative 21. Good job. Good job. So, yeah, that's how you do it. So, let's see. Is anybody else here? Sujit, hello? You seem to be changing your name a lot. Okay, so how about you do this one? Sujit. Hello, Sujit. How about you do this one?
He's keep on muting himself for some reason.
Hello, Sujit. You're muted. Yeah, can you tell us what you're doing?
I don't get this problem.
Okay, so basically what you have to do is you see how there's like an f of 3 right here? There's like an f and then there's a parentheses 3. And then if you see over here, there's an f of x. So basically, if you match up these two, you can like implicitly guess that you have to basically put 3 in place of x. Every time you see an x, you just place 3 there. You just replace 3 over there, so you substitute x as 3, and then you solve the problem that results.
Hello?
Yeah? I think Sujit is doing the problem.
There's 2 people that can't hear us. That is Munawashi and where's the other person? I forgot. Can you type in the chat if you can hear me? I can hear you. I can't hear you. You can't hear me? Then rejoin me. Like, why am I even saying that? You can't even hear me.
I can hear you guys.
Okay. Okay. Wait, Lisa, why are you the only person that can chat?
Because he's the host.
I disabled the chat.
That's not fair.
Mm,
Now, can you guys?
yeah, I can hear you.
They can hear you.
Can you hear me?
Go. Yes, yes, yes. I can hear you. Sound, my sound better. Go, Leslie, rejoin.
Isn't it break time?
Okay, now I can hear you. It is break time. It is break time.
Okay, no, it's not break time yet. I think Sujit is solving the problem. Hey, Sujit, are you done?
It just changed his name, I think. No, not yet. Did he just change his name?
It's not break time yet. It's not 8 o'clock yet. Maybe we'll have break at 8:05 or something.
Why do we even have a class till 9? I still need help.
Okay, so did you get this far?
Yes, I got that far.
Okay, so what you do next is you have to do 3 to the power of 3. That's 27, and then you have to multiply that by 2 because the problem says so. 27 times 2 is 54. Minus 21 times 3 to the power of 2. 3 to the power of 2 is 9. 9 times 21. Let's find that out. 9 times 21 is 189. And then you have plus 42 times 3. 42 times 3 is 126. And then you have plus 48. And then since you have like this super easy equation, you can just plug this into the calculator and it will automatically solve it for you because calculators are cool. Okay?
I got 39.
I also got 39, so I guess that's how you do the problem then. Good job. It's break time now. You can have break time until 8:05. Is there any difference? I don't think there is. Oops. Well, this happened. I don't know. They're mostly like. I'm pretty sure most of them are just like my mom's friends or something, or like part of the GCS group or something like that. You know. So let's get started doing this stuff. Okay, so let's see who hasn't gone yet. Let's see. How about middleish? Middleish, you can do number 1. So it's saying divide this number by this polynomial. So it's saying do something like x to the power of 3 minus 11 x squared. No, middleish is the one who's doing the problem. Okay. And you divide this by x minus 6. This is a minus. Which would be? I'm pretty sure that's not true. Just solve this problem first. Don't worry about the answers.
Yeah, and there's not even an x plus x on there, so why are you saying that?
He said x plus 6. And yeah, yes, x plus 6 is on there.
Oh, I thought you said x plus x. I'm like, what? X plus x isn't even anything. It's like 0 something.
It's 2x.
X is like 0.
X plus x is 2x. Okay, middleish, do you know how to do polynomial division? Or polynomial long division? I covered it in the slides. Were you listening when I was doing the slides?
Yeah.
See, remember this? Yeah, we just do that. It's just normal division, but it's like for polynomials.
But we don't have like 2x's.
Wait,
What do you mean we don't have to what?
I don't understand what you mean.
Wait, can you go back to the picture?
Okay.
Okay, so it's 11x power 2, right?
Yeah, negative 11x power 2. Yeah, it's negative 11x to the power of 2.
No, can you even do this? I'm pretty sure I can't because I don't understand a thing about this. Well, if you round it up, I would say it would be x minus 6 as the real.
Okay, middleish, do you know how to do this?
I think he knows.
It's fine if you don't. I can explain it.
He knows the way. I think he knows like with me, but he doesn't understand. You know? It's fine if you don't know it, anyway. No, I know.
Then it seems like you're guessing it.
Yeah.
Can you tell us exactly how you're getting your answers?
So I'm doing whatever. times 11 is 121 and 120 divided by 36 is 4.5833 rounded up to 6.
Okay. So what you're supposed to do is this is just like normal division. So tell me how you would do something like, let's say 343 divided by 7. So how would you do this?
Wait, you want me to? Okay. Is there it's 20. I mean, it's 49.
So how did you do that?
7 times 2 equals 28, and there's an extra 6. 7 times 2 equals 28, is it right? I mean, 7 times 4.
Yeah, good job. And then?
And then you have 6 left, so it's 64. And 7 times 9 is 64.
Yeah, so basically you just kind of do the same thing for this, except with like polynomials. Yeah.
Okay, now
Okay, so what you do is you do x minus 6. So how do you get x to the power of 3? So how do you... Okay. So basically I guess we're gonna wait until he comes back. Or does anybody kind of understand how to do this? That doesn't necessarily mean that you're smarter than calculators. That doesn't necessarily mean anything anymore. Yeah, but most people don't know that.
But still,
So?
people that created the calculator are smarter because, you know,
No, not necessarily.
if they didn't know math, how would they know? Okay, that would be 3 times 2.
Wait, what are you talking about? 3 times 2? But where did 3 times 2 come from? Okay, so what you're supposed to do is you're supposed to look at how x turns into x to the power of 3, because that's the first thing in here. So basically, how does x turn into x to the power of 3? Do you know, Middleish? You have to multiply it by x to the power of 2, right? Because x to the power of 2 times x, because like, yeah. So you just put x to the power of 2 on top, and then you multiply x to the power of 2 times this, and you erase what's down here because it's useless, and you basically solve everything. So that's basically just like a long division. So you have x to the power of 3 over there, and then you have minus 6x to the power of 2, because I learned it, which you can also do. Okay, and so now you subtract this value from this value. That means you multiply this whole thing by -1. And basically you add the whole thing together. This cancels out. And this becomes negative 5x squared plus 36x and then now you just repeat the whole process until you have like a full factor. So why don't you do it from here, Milish? Do you understand what kind of what's happening? No?
All I understood was if you want to do x, you need to times it by 2.
You actually want to times it by x to the power of 2 because of the exponent product rule. So basically it's just like, okay, whatever. It's basically like, it's just like normal division, okay? So you have this, just think of this as like a number, and think of this as another number, and so you have to first look at this first number and this first number. No, that's not the answer. Okay, so basically what you do is you have to like multiply, so you know that x times x to the power of 2 is x to the power of 3, right? Do you understand until there?
Yeah.
So basically now you have to multiply x to the power of 2 times negative 6, because this negative 6 is also part of this divisor, right? Right? Okay, so do you know what a divisor is? So a divisor in a normal like division problem, normal division problem was like this, and then there's like 3, 4, 3 inside, and you have 7 over here. This is the divisor, right? This whole number. Hello, can everybody hear me? Midlish, are you here? Okay, it seems like Midlish left accidentally or something, maybe he...
Yeah, I can hear you. Yo, shit.
Okay, it seems like Midlish is gone. Okay. So Neil, do you want to do this one? Does anybody want to do this one? It's just like normal division. Here, let me just put a video on it. I tried to explain it as much as possible, but I guess I'm just not a good explainer. So, we're gonna watch a video on it, which is the logical thing to do. Okay. Let's do this one. Oh, I don't think you can hear.
I can hear.
And I'll also show you how to do it using
Hmm?
algebraic formulas, which is a bit of overkill for this. I just want to show you that it's not fundamentally anything new. It's just a different way of doing it. But it's useful for more complicated problems. You could have also written this as 2 goes into 2x plus 4 how many times? And you would perform this the same way you would do traditional long division. You'd say 2, you'd always start with the highest degree term. 2 goes into the highest degree term. You would ignore the 4. 2 goes into 2x how many times? Well, it goes into 2x x times. And you put the x in the x place. X times 2 is 2x. And just like traditional long division, you now subtract. So 2x plus 4 minus 2x is what? It's 4, right? And then 2 goes into 4 how many times? 2 times. Positive 2 times. Put that in the constant place. 2 times 2 is 4. Subtract remainder 0. So this might seem overkill for what was probably a problem that you already know how to do and just a few steps. We're now going to see that this is a very generalizable process. You can do this really for any degree column that you're dividing into any other degree column. So let me show you what I'm talking about. So let's say we wanted to divide x plus 1 into x plus 1 into x squared plus 3x plus 3x plus 6. So what do we do here? So you look at the highest degree term here, which is an x, and you look at the highest degree term here, which is an x squared. So you can ignore everything else, and that really simplifies the process. And you say x goes into x squared how many times? Well, x squared divided by x is just x, right? X goes into x squared x times. You put it in the x place. You put the x place right here, or the x to the first power place. So x times x plus 1 is what? X times x is x squared. X times 1 is x. So it's x squared plus x. And just like we did over here, we now subtract. And what do we get? X squared plus 3x plus 6 minus x squared. Let me be very careful. This is minus x squared plus x, because I want to make sure that negative sign only applies to this whole thing. So x squared minus x squared, those cancel out. 3x is going to be a minus x. Let me put that sign here. This is minus x squared minus x, just to be clear. We're subtracting the whole thing. 3x minus x is 2x. And then you bring down the 6, or 6 minus 0 is nothing. So 2x plus 6. Now you look at the highest degree term, an x and a 2x. How many times does x go into 2x? It goes into 2 times. 2 times x is 2x. 2 times 1, 2 times 1 is 2. 2 times 1 is 2. So we get 2 times x plus 1 is 2x plus 2. We're going to want to subtract this from this up here. So we're going to subtract it. Instead of writing 2x plus 2, we can just write negative 2x minus 2 and then add them. These guys cancel out. 6 minus 2 is 4. And how many times does x go into 4? We could just say that 0 times. We could say that 4 is the remainder. 4 is the remainder. So if we were to if we wanted to rewrite x squared plus 3x plus 6 over x plus 1. Notice this is the same thing. It's x squared plus 3x plus 6 divided by x plus 1. This thing divided by this. We can now say that this is equal to x plus 2. It is equal to x plus 2 plus the remainder divided by x plus 1 plus 4 over x plus 1. This right here and this right here are equivalent. And if you wanted to check that, if you wanted to go from this back to that, what you can do is multiply this, multiply it by x plus 1 over x plus 1, and then add the 2. So this is the same thing as x plus 2. show you that it'll always work. I want to go above quadratic. So let's say we have 3x to the third minus 2x squared plus 7x minus 4. We want to divide that. We want to divide that by x squared plus 1. I just made this up. But we can just do the algebraic long division and figure out what this is going to be, or what this is being simplified with. X squared plus 1 divided into this thing up here. 3x to the third minus 2x squared plus 7x minus 4. Once again, look at the highest degree term. X squared goes into 3x to the third how many times? So it's going to go into it 3x times, right? You multiply 3x times this, you get 3x to the third. It's going to go into 3x times. We have to write 3x over here in this x times. It's going to go into 3x times, just like that. Now let's multiply. 3x times x squared is 3x to the third, right? 3x times x squared plus 3x times 1. So we have 3x over here. I'm making sure to put it in the x place. And we're going to want to subtract everything. So what do we have? What do we have when we do that? These cancel out. We have a minus 2x squared. And then 7x minus, I just left a 0 in there. 7x minus 3x is plus 4x. So we have a minus 4. Once again, look at the highest degree term. X squared and a negative 2x squared. So if x squared goes into negative 2x squared, negative 2 times. Negative 2. Put it in the parentheses place. Negative 2 times x squared is negative 2x squared. Negative 2 times 1 is negative 2. Negative 2. Now, we're going to want to subtract these from there. So let's multiply them by negative 1, or positive. These two guys cancel out. 4x minus 0 is 4x minus, switch colors. 4x minus 0 is 4x. Negative 4 minus negative 2, or negative 4 plus 2, is equal to negative 2. And then x squared now it has a higher degree than 4x, and the highest degree here. So we view this as the remainder. We view this as the remainder. Remainder. So this expression, we could rewrite it as being equal to 3x minus 2, that's 3x minus 2, plus our remainder, 4x minus 2. All of that over this term plus 1. Hopefully you found that satisfying.
Okay, guys, did that just make it more confusing, or did some of you actually understand it?
I didn't understand it.
I did not understand.
Okay.
It made sense, but also kind of didn't.
So, how much did you guys understand up to? So, you have x to the power of 3 in here, minus 11 x to the power of 2, plus 36 x minus 36. Okay, and it says you have to divide it by x minus 3, right? Okay. So what we have to do is we have to look at this, and we have to look at this, and as you can see, this is x, and this is x to the power of 3. And so you have to multiply x by x to the power of 2. So x to the power of 3. So we have to do x to the power of 3 divided by x So we get x to the power of 2. So we put x to the power of 2 on top. And since we know that x to the power of 2 times x is x to the power of 3, we now have to do x to the power of 2 times negative 6. Right? That is obviously negative 6. Did everybody get it up till this point?
Yes.
Neil, did you get it? Hello? Okay. So what don't you understand? Where did you understand up to?
I don't understand the whole thing.
So
Yes, Dad, I don't get any of this.
It's kind of hard.
it shouldn't be if you know just like normal division, then this shouldn't be if you know just normal long division. So
I get that part, but how do you divide it in algebra? But how do you do that?
you do the same thing. So let's see this, okay? So you're doing 36 divided by 2, right? So you first look at this number and you look at this number, right?
That's easy. That's
Okay, wait. Don't do it your way. I know it's super easy. Just do it this way, okay? So you look at this number and you look at this number. How many times does 2 go into 3?
one.
Yeah, once. So you put one up there, and now you have to you now have to multiply 2 times 1, and you get 2, right?
Yeah, that's how I do it. That's how I do it.
Yeah, and then you have to subtract. Yeah, everybody knows that. Yeah, but like, do you understand the process of how you're getting that?
That's what I use. That's what I use every time I solve this.
Yeah, you just do the exact same thing, but with this.
Algebra. How do you do it?
Just don't think of it as algebra. Just think of it as a normal number.
So take away the variables.
Don't. Just think of it like that. So what would you do first? So how many times does x go into x to the power of 3?
Then x goes like 3 times.
X to the power of 2 times.
X to the x. How much does x equal if it's 2 times?
Um, that doesn't matter. It's just x to the power of 2 times. X to the power of 3 divided by x is x to the power of 2. So now we can multiply x to the power of 2 times this, and we get this. Now we have to subtract this value from this, and whatever we get, we have to add this, and we have to bring it down to the bottom. So we have negative 5x squared plus 36x. And now how many times does x go into x? How many times does x go into negative 5x squared?
I don't understand. What do you mean? Like how much does it go? I don't know.
Wait, how many times x goes into negative 5?
X. How many times does x go into negative 5x squared?
How do you even do that?
You just cross out x, and now you take out this exponent because x to the power of 2 divided by x is x, because x times x is x squared. See, so remember like the exponent rules?
Then it's minus 5x.
Yeah, good job. Yeah, that's basically it. Minus 5
Okay.
minus 5x. And now you just multiply minus 5x times x minus 6, and whatever you get, you have to subtract from this. So what's minus 5x times x minus 6?
That would be 30x.
Since you're doing x minus 6 and you're distributing negative 5x, you have to do like negative 5x times x, and that equals negative 5x squared. And then you can do negative 6 times negative 30x, and that's positive 30x. Remember, because there's an x over here.
Okay, that makes sense.
Yeah.
Yeah, like it's kind of hard. I get where I like know how to like make like equals. So like I know how I know how much like minus 5x squared is equal to x minus 5x, but I don't get the whole point.
What do you mean?
Like I don't get what's like after what what x is equal to.
You don't need to know what x is equal to. What x is equal to doesn't matter. X can be any number. You're not trying.
Just tell me like what is x equal to if it's 5x squared?
I never said that.
5x squared.
I never said that. I said, how many times does x go into negative 5x squared? So I'm asking you to divide.
Okay. Yeah. So I don't know how to go go. I don't understand the things after that.
After what?
After how much times does x go to x negative 5x squared?
Okay, so basically what you have to do is you have to multiply negative 5x. So you have to multiply negative 5x by x minus 6.
And how are you supposed to do that?
You just multiply this first, and then you multiply this next.
So what's minus 5 times x minus 5x times x? That is minus 5x squared.
Yeah, you're right. Yeah. Keep going.
And then you multiply 5 and 6.
Negative 5 and negative 6, yeah.
That's negative 30.
That's positive 30.
Wait, negative and negative equals to positive.
Yeah.
Okay, yeah, positive 30.
And then there's an x. There's a 5. This is a 5x. So you just add an x over here.
Positive 30x.
Yeah. And then that's what you write down here. Do you understand now? Yeah. It's really not that difficult. It's really not that difficult at all.
Same.
So how about you keep going? So, Neil, what do you do next? After this. We got this. So, what do you do next?
So then you do 6x minus 30.
No, you do how many times does 6x, how many times does x go into 6x?
X minus 6x squared.
No, I'm asking you 6x.
6x squared.
No. I'm asking you 6x divided by x.
How are you supposed to do that?
This just cancels out.
So then it's 6.
Yeah, it's 6, that's it.
Oh.
And then you add 6 over here. And now you have to multiply 6 times x minus 6. So you do 6 times x minus 6. Okay, so what do you get?
So 6 times x minus 6. So 6 times x is 6x, right?
Yeah?
And then 6x minus 6. That's 0.
No, you have to do 6x times negative 6.
Oh, times negative 6. So positive and negative is equal to negative?
Yeah. It's negative 36, yeah. Good job, Sujit.
So negative 30 minus negative 30. Wait, so it's going to be a negative, right?
What are you talking about?
The answer is going to be in negatives, right?
No. Okay, so now you're supposed to subtract this number from this number. Okay, so you just multiply negative over here, and you...
But they're the same thing. They're the same thing.
Yeah. What's 1 minus 1?
0.
Yeah. So what's any same thing minus that same thing?
0.
Yeah. So this is obviously the same rule applies here.
That's what
It's
I
0.
said. I said 0.
Oh, good. Then the answer is this up here. This is the answer for the division problem.
Oh, wait, what? That's the answer? So the answer is an equation?
It's an expression, yeah.
Oh, so it's not like an actual answer. It's an expression. Oh.
This is an actual answer.
I know, but it's not like this number is like 36 divided by 66. It's not.
Oh, no, yeah, it's not that. Sometimes it can be that, but like most of the time, no, it's not that.
Okay. Class is going to end in 10 minutes.
Yeah, so Sujit, what exactly don't you understand? We're gonna do this again. Let me just clear the screen. Because that's what you get when you divide an expression by another expression. You get one more expression.
The answer has to be 0 if you want it to be an answer. Like when you like solve it, at the end there has to be a 0, or else it'll be like a remainder or something.
Yeah, there's gonna be a remainder. There doesn't necessarily have to be a 0. It's just like normal.
Wait, I'm saying like,
It's just like what happens if you have a remainder in normal division. Let's say you want to do like 21. Oops.
like I'm talking like if you want to figure out the answer for polynomial division, in the equation, at the end there has to be a 0. Like in normal division, there has to be a 0 too, right?
Yeah.
Okay.
Okay, but what happens if you have like a remainder in normal division?
Or you can just write an arbitrary remainder in it.
Yeah. So basically, like Neil said, so just normally in like numbers, yeah, you do that. But like since this is polynomials, you can't really have like a decimal point in polynomials. So you do what Neil said, and you write the remainder. But when you're dividing like polynomials, you have to like write the remainder as like the remainder, whatever the remainder is, which is represented by r, divided by the divisor.
Remainders are represented by r, while decimals are represented by a point.
Yeah. So you have to put the So now you have to add this on to the answer, and that's how you get your final answer if you have a remainder. So you just do remainder divided by whatever the divisor is, which is like this number right here, remember?
Why did you join last time? It said that Ritwik was there. It said that Ritwik was there in last class.
He wasn't really there
Yeah, he wasn't really there, but why was he there?
because that was because I don't know. Don't ask me. Ask my brother.
He just wanted to.
I guess so.
Okay.
Okay. So I guess that's the end of class then. See you guys all tomorrow. Okay.
Bye, you guys.
Tomorrow we're gonna practice a little bit more of the division problems. So yeah. See you guys tomorrow.
Bye. Thank you.
Do we have class tomorrow or no?
Yes, we do. See you guys tomorrow. See you tomorrow.
Bye.
Yeah. Yeah.
I might not be able to join class because like I might have another class.
There's always the live stream.
What?
There's always the live stream.
Oh yeah. So I actually have another class. It's at 8 o'clock. I just wanted to tell you it's called Shima, and I have to join it at 8 o'clock, so that's why I might miss 1 hour of class.
Okay, you can still watch the recording though, so it's on YouTube on the channel. So
Okay, bye.
yeah, see you tomorrow. Bye.